Welcome back to the second part of my video tutorial on how to create your own algorithmic trading system. Therefore, we click on the MySQL workbench, we establish a connection to the server, and then we click on Create a new schema. We then insert a meaningful name. In my case, this is securities_Yahoo. I choose this value because we use the financial data coming from Yahoo. Choose a default location and then hit the apply button. Script is successfully executed. There you can see the new database, and we begin by adding a new table. Also enter a meaningful name here. For my example, I opted for realtime_data. To enhance the speed of your database, it is always recommended to use a primary key. We will stick to the recommendation and create a first column with the name ID. We enter the data type, which is big integer. We will use this because the security asset price data will become quite large. So it is always useful to use big integers if you have a lot of data to store. We also set the primary key, the not null value, and we mark the auto increment option. In the next column we will store the ticker symbol. Of course, if you don't have any column that identifies your assets, you cannot distinguish between any entries of different assets. We will store it as the data type varchar, which is a variable character length with a maximum of 45 characters. The bid and ask prices are stored as decimals, with 19 digits before and 4 digits after the point. For obvious reasons, they should be not null. 19 digits may look pretty awkward at first, but if you have an equity which is priced in an exotic currency and you convert it directly into a dollar, some high choice could make sense. And in this case we are already prepared. I will also add 2 more columns for real price data, despite that Yahoo Finance has the structure prepared but does not deliver real-time data yet. But possibly your data provider already delivers real-time data, and in that case you are ready to go. Of course we will store it also in decimals with 19 digits before and 4 digits after the point. Please notice that in this case we leave the not null option unmarked so that the columns can contain null values. Else we are required to deal with null values on our own. The next column will contain also a price data, but in this case this will be last trade price, and as it is self-explaining, the last traded price at which the asset was negotiated will be stored. So in case that an asset or an equity is illiquid, usually bid and ask prices have a huge spread, and therefore the last trade price is in between of both. Again, it is a decimal and should be not null. Now we are finished with all the price data which we will store in our database. In the next column we will store the last trade date time, which is also pretty self-explaining and which stores the date time when the last trade was exercised. Total volume will be a column of data type big integer. This is because total volumes can reach a quite high number at the international securities exchanges. Depending on your data service provider, you can mark the not null option or just leave it out like me. In the next column we will store again a date time. This time this will be called query time, and it has a simple reason. Yahoo does not deliver seconds in the last trade date time, so we will have to insert some kind of own time, so to distinguish between assets which are exercised in the same minute. In this case we will also mark the not null option, because later we will use the time of our operating system to insert it in as a query time. Lastly, we will just set the default values for all the columns where we set or where we unmark the not null option, and we set null as the default value. We have just finished the creation of the first table of our database, so we can hit apply to execute all the changes to our database. In the next pop-up window you can review the changes before we can finally apply them to our database. Let's check if we've made an error. No, the script was executed successfully, and we can move on with the creation of the unique key. A unique key is required to prevent us from inserting the same row at multiple occasions into our database. So let me check that in my already existing database. Okay, so I want to alter the table indexes, and there you go. Okay, take your ask it out. And the same index I will apply to our database, so I insert a simple name, index 2, but the type must be unique, and we click on ticker ask bit and last trade price and last trade date time, and these 4 columns will specify the unique key, and that means that any new row which has the same values in ticker, ask bit and time is recognized as such, and so it isn't inserted into the database at all. Now I want to make a copy of the table which we've already created, and while I explain to you why we are doing that, I will speed up the video recording a little bit. Databases that contain real-time price data and stores these data permanently can or will become quite large in a short amount of time, and therefore you have to think about strategies to speed up the database in general. The difference between both tables is that the temporary table will contain only data which is not older than 7 days. We can accomplish this by simply deleting data that is older than 7 days. Usually these periodical deletions will take effect when the system is in idle, so I will choose a time when the system is in idle or when the exchanges are closed. If you're trading on currencies, you will possibly not encounter any point during the day where all the exchanges are closed simultaneously. If you want to run simple algorithmic trading and you do not have any research questions to examine, you can simply use a table like my temporary table as your main table and leave out one of them. So just store the 7 last days of price data. To all the others I recommend to create a main table and a temporary table. If you imitated all the steps correctly, you should arrive to the review window, and we click on apply again. Now we just have to add the unique key feature to the temporary database, and then we are finished. As we did previously, we set a name, and we click on ticker ask bid, last trade price and last trade date time. Then we just have to apply this to the database, and that's it. Fortunately, the script was executed successfully, and we can close the tab with the temporary data table. Now we will create a table that contains the ticker symbols of the assets which we want to track. Therefore, we right-click on Tables, create New Table, and give it a meaningful name. I will use just symbols as the name for the table, but if you choose another name, just pay attention later when we create the R scripts that you use your own chosen variable names and table names. The first column will again contain a primary key of type integer with 11 digits only. Since the table will not get so large, this is a quite good choice. Don't forget to mark the auto increment option, and then we can create the next column. It is ticker ID, also self-explaining, and it is a variable character of 45 characters at the maximum. Also mark the not null option. Then we can go on and create the third column. It is an variable character of the exchange ID. I will mark the not null option, but this is not necessary, so please make sure that you have at least the ticker ID marked as not null. Let me just check what comes next. Okay, this is name, sector name, and sector ID and quantal ticker. Even if the international security identification number should be standardized, many data providers have their own ticker symbols. I store them separately in columns. The name variable will be a character of 255 characters at maximum. Some companies have quite large names. Also, sector name is a variable character of size 145. Sector ID will be an 11-digit integer. If I remember correctly, Yahoo uses some integer values to classify their industries. If you're using the NICS, you should use a variable character or something like that. All the letter-free variables can be null values, so we set the default as null, and we don't mark the not null option, of course. If you're done with that, we hit on apply and execute the scripts. Then we also create a unique index for the symbol table. Therefore we click on the indices tab, insert a meaningful name. Again, I will use index underscore unique and set the type to unique. The key is composed by ticker ID and exchange ID. Apply the script and close the symbols table. Now we will add the procedure which clears the price data older than 7 days from the temporary table. Therefore, click on the upper left item, which is just below the house item, to open up a new SQL tab in which you can execute SQL queries. With the first command, we switch to our securities database, and we'll just click on the flash item to execute the query. We now want to register an event to the database, and it is executed each day, during the midnight when the database is in idle mode, and should delete all data price which is older than 7 days. Therefore we say create an event and give it a name. In my case it is delete old entries. Then the schedule, which is on schedule every first day, and we give it a start date. In my case this is the 20th of July 2015 at 2:30. Of course you can adapt the schedule, for example, to every 1 week or every 1 month, or you can adjust the start time, but make sure that the start time is in the past, so that deletion of the price data older than 7 days starts immediately. As a recommendation, use a starting time during the midnight when the database is in idle or when the database has not to process much. After the signal word do, the command block, which contains all commands which are executed against the database, starts. Here it becomes clear why we've created an additional temporary security price database, because we only want to delete data from that table and not from our original real-time data table, because all data which is stored in the original table is stored on a long-term basis. Therefore we say delete from our database and table realtime underscore data underscore temp, where last trade date time is lower than the actual time minus the interval of 7 days. Notice that we only use the singular version of day and not days. If you use days, it doesn't work. In the last step we make sure that the event scheduler of SQL is activated. Therefore we simply assign on to the global variable event scheduler. Please don't forget to write the semicolon at the end of the line. Now we can run the script with a click on the flash button. In the frame at the bottom you can see if the script is executed successfully. You can find your registered events also if you right click on your database and hit on Schema Inspector. Just click on the Events tab and there you go. We have entered successfully the Delete Old Entries event. We finished the creation of our first MySQL database, and right now we move on and create the virtual trading accounts database. We do this to be able to track the performance of our algorithmic trading strategies. But now back to the creation of the database. Click on Create a new schema, enter a meaningful name. I choose accounts, and click on Apply, and again on Apply to successfully execute a script. There you go. We have a new accounts database. Right click on Tables, create a new table with the name Account. As always, the first column will contain our primary key. So we give it a name ID underscore client, data type integer of 11 digits. The primary key and not null values are already marked, and we set the auto increment feature. To make the database as easy as possible, I will just use 2 columns. So the first column will be last underscore name, self-explaining again, which will be a variable character and should be not nil. And the third row will be account underscore number, which will be of data type integer. Of course, a real accounts database contains much more information, but for our task this should be sufficient. Then we create an unique index to prevent us from double or multiple entries into our accounts table. It is composed by last name and account number. Okay, that's it. Now we want to create tables which contains transactions. So we right click on tables, create table, and in this table we want to store all the executed transactions. That means that if the transaction manager script identifies any pending transaction to be executed, they are written into this table. Again, we start with a primary key column. I name it ID_transaction. We give it a data type of type integer, and we mark the primary key not nil value, but in this case we also mark the unique option. We don't mark the auto increment option here because ID_transaction is copied from the pending transaction data table. The second column is the ticker column, variable character and not nil. The third column will be of a new data type. It's called type transaction and it will be an enumeration. This means that only a limited set of values can be inserted into this column. We want the database to accept character strings by and cell. Mark the not nil option. As default, I set by, but you can also choose cell or leave out the default value. The next column will contain the type of the security, and it is also an enumeration. At first I will only trace stock and bond prices, though for me it is sufficient to just use this character strings for the enumeration values. Default is here stock again, but if you're trading on commodities or you want to test your strategies with other equities or assets, just extend your enumeration. Then we create a column for account number of data type integer of 11 digits. We mark the not nil option. In the next column we will store a bool value. It is called execution next underscore price. And bool values are somewhat awkward in SQL. They are called tiny integers, and therefore we use tiny int in brackets 1. And we will use this value later to decide if the algorithm has posed any execution date in the future, or it simply said okay, buy at the next possible price. Then we specify a datetime column, so it is called execution underscore datetime. Also self-explaining, it simply contains the time when the order was executed. Well, I think this is obvious why we need this information to fully retrace how our algorithm has worked out. We also set the not null option to this column. We also need to store the price information, of course, which we will do in the next column. It is called execution underscore price, and this column should contain decimal values of 19 digits before, respectively 4 digits after the point. And for obvious reasons, we also mark the not null option. Now we need information about the volume, so we created a column called order underscore volume, and this is of course of type integer, because it is not possible to buy, for example, half of a share. At least I haven't heard of. Then set the not null option, and I also set a default value of 1. In the next column we store the order price. In conjunction with execution price, this is useful information, in particular if your shares are illiquid and consecutive prices contain large spreads. For obvious reason, the data type should be the same as in execution price. I also leave out the not nil option. Instead I enter nil as the default value. In the last column we will store a date time again, and it is called execution underscore price underscore date time. Execution price date time may differ from execution date time because we use financial data from Yahoo, and it comes with a 15 minutes delay. So give it the data type date time, set the default value to nil. That is everything we need so far, and now we can hit the apply button and then apply again, and as you can see the SQL script was executed successfully, and we can move on to create the unique index. I will look up the index in my other database because I can't remember exactly which columns together form the unique index. Therefore I look up the values of the table. Okay, it is ID underscore transaction, which makes sense because we are getting this information from the pending transaction database, and if a order is executed, it is deleted from the pending transaction database, so no multiple rows can be inserted into the executed transaction table. Hit apply and close the tab. Okay, I already named it. Now we are creating the pending underscore transaction table that stores all the pending transaction. That means transactions which are not executed yet or which are to be executed in the future. Because on exchanges you can set a order date, and that means that the order is not executed before that date. As always, we begin with the creation of the primary key column, which is called ID underscore transaction. Here you can see where the ID underscore transaction value from the executed transaction table comes from. When I synchronize the video, I've recognized an error, so please mark the auto increment option in the ID underscore transaction column. The second column will contain the ticker symbol, so it is a variable character and should be not nil. The third column contains the type of the transaction. It is an enum value of buy and sell, the same as we did in the executed transaction table, and we mark it also as not nil. I set the default value to buy, and the next column is called type underscore security, the same as in the other table. It is also an enumeration value. Here it is stock and bond. We also mark the not null option and set the default value to stock. Of course we have to store the account number to retrace who set the order. Of course the data type should be the same as in the other tables and give it an integer data type. We also mark the not null option, and then we can move on to the next column. It contains the order price, so it should be a decimal of 19 digits before and 4 after the decimal point. But in this case we don't mark the not null option. The reason to do this is that we later explicitly create a column called execution next price, and if it is set to 1 or true, that means the order is executed at the next market price. So we do not require an order price for the execution. Of course, each valid order requires a volume parameter, so we create a column order volume that contains integer values at maximum 11 digits. We mark the not null option and we set the default value to be equal to 1. The next few columns will contain date values, and since it requires some insights into the main thoughts behind, I will discuss them in greater detail right now, so just imitate the steps I show you on the screen while I explain to you the usage of the date-time variables. But let me first create the execution next price column, which I forgot to insert. So execution next price, tiny integer, so 1 or 0, which is the Boolean value for the SQL database. We move it up in the list and we set the not null option and the default value to 0. Now we can continue the creation of the datetime columns. As I have already mentioned that we will use a script called Transaction Manager to periodically compare if pending orders are required to be executed. We need to compare the order time against the last trade date time in our securities master database. Yahoo sends us the last trade date time from the specific region where the asset is traded, but we will fill the query and order time with our system time, which is not region specific, but specific dependent on your system, what you've adjusted it to. And then we have to either translate the time from the Yahoo we obtain into our region time, or we have to translate our system time into the region time of our traded security. Therefore we need order time underscore CET, which is my Central Europe time here in Germany. Order underscore start underscore time and order end time are self-explaining. Last search date is used because we only want to search all the prices which we have not already searched through, which should increase the speed of our queries. This is updated via the Transaction Manager scripts, therefore set a default value which is in the past. Hit the apply button and the script should be executed successfully. As a last step we have to create the unique index, but I can't remember, so I have to look it up in my existing database. Okay, there you go. It is composed by ticker, type transaction, type security, account number of course, and all the other marked columns. So go to the Indexes tab, insert a name and click on the same values as I do. Okay, these are completely equal. Now we can hit on apply, script is executed, and we finally finish the creation of the pending transaction table. Let's recap on the steps we've did so far. Okay, we created a database called accounts, which contains tables account with columns ID, client, name and the account number. We also created a table called executed transaction with column ID transaction, ticker, type of transaction, type of security, account number, execution next price, execution date time, execution price, order time, order price, and execution price date time. We have also created a table called pending transactions with the ID of the transaction, ticker, type of transaction, type of security, account number, order price, order, volume, execution next price, the order time in our system specific time zone, an order start time, order end time, the last search date, and the time zone. We have also created a database called Securities Yahoo with a table called real-time data and columns ID, ticker, ask and bid in real time, the last trade price, the last trade date time, total volume column, and a column for the query time. We minimize the tree structure so that we don't get confused, and we also created a symbol table. I think that I forgot a time zone variable, so we click on all the table and add a column for time zone of 7 characters at maximum, and we set not null, of course, apply stuff and close the tab. Now we can take a look into the symbol table. It is composed by columns ID, ticker ID, exchange ID, name, sector ID, and time zone. And that's it with the creation of the whole bunch of the databases we will need later in the script. Hope to see you in the next video again. Bye!